Now for problem number 7. So this problem is asking which of the following is the more important resonance form? To determine the more important resonance form of a molecule, you're going to want to look at the overall charge of the molecule and the formal charges of the individual atoms. So the structure with the least number of formal charges on the total number of atoms will contribute more to your resonance form, meaning that if it has 3 atoms with a formal charge, that will contribute less than a resonance form that only has 1 atom with a formal charge. Also, your atom with the greatest electronegativity should carry the negative charge, meaning in this case, you have nitrogen, carbon, and oxygen. So oxygen is going to be your most electronegative atom. So you want the oxygen to have the negative charge if there is one. Additionally, you want your least electronegative atom to carry any positive charges there might be. So in this case, the least electronegative atom is carbon. So if there is a positive charge, it should be on the carbon atom. So now we'll go ahead and look at structure 1. So actually, before we do that, remember that to determine your formal charge, that will be equal to the number of valence electrons, and you get that from looking at your periodic table, minus the number of bonds plus the number of lone pair electrons. So I'll do these examples. So if you have structure number 1, let's do nitrogen first. So if we're looking at nitrogen, the number of valence electrons nitrogen should have is 5 minus the number of bonds. So nitrogen is bonded only once to carbon. So its number of bonds is 1 plus the number of lone pair electrons. In this case, it has 3 lone pairs. So there are 6 lone pair electrons. So the formal charge of nitrogen is equal to -2. Now if we look at carbon, it's supposed to have 4 valence electrons minus, let's see, it's bonded once to nitrogen and 3 times to oxygen because that triple bond. So it has 4 bonds plus 0 lone pair electrons. So its formal charge is 0. And if we look at oxygen, it has 6 valence electrons minus, let's see, it's bonded 3 times to carbon, and it has 1 lone pair, so that means it has 2 lone pair electrons. So it's going to have a formal charge of 1. So if we can double check our math by making sure these numbers add up to our total charge of the molecule, which is -1, and they do. So that's good. That's a good resonance structure. Now to look at structure 2. So again, if we have nitrogen, we have 5 minus 4 plus, that should be a 2. 2, because it's bonded twice to carbon, plus 4 lone pair electrons equals -1. And then we have carbon, which is again bonded 4 times with no lone pairs. So it has a formal charge of 0. And then if we have oxygen, it's going to be 6 minus, it's bonded 2 times and it has 4 lone pair electrons. So that's also going to be 0. And then if we have number 3, we can, again, that's equal to -1. So we know that we did that right. If we have our third example, we have nitrogen is going to be 5 minus 3 plus 2 because it's bonded 3 times to carbon and it has 2 lone pair electrons. That's going to equal 0. We're going to have carbon. It's bonded 3 times to nitrogen, 1 time to oxygen, and has no lone pair electrons. So that's going to be also equal to 0. And then we have oxygen, which has 6 valence electrons, is bonded 1 time to carbon, and has 6 lone pair electrons. So its formal charge will be 1. So now we have to determine, out of these individual formal charges of the atoms, which structure contributes most to the resonance form? Well, we can look up here at our rules. So the structure with the least number of formal charge will contribute more. Well, this structure, structure 1, has 2 formal charges, or 2 atoms with formal charges, and the other 2 both only have 1. So we know that it's not going to be structure 1. Now, so the atom with the greatest electronegativity should carry the negative charge. Well, looking at these two, we have in example 2, nitrogen has the negative charge, and in example 3, oxygen has the negative charge. But we know that oxygen is more electronegative, and therefore structure number 3 will contribute more to the resonance form because it has the negative charge on that really electronegative atom. All right, moving on to practice problem number 9. Draw the molecular shapes and predict the bond angles. So, to draw the molecular shapes of these atoms, we are going to want to start off by drawing the Lewis structures for them. So, if we do, I'll start up here with ClO3 minus. So again, we are going to want to determine the total number of valence electrons, which will be equal to, let's see, we have 18 plus 7, 26. Our central atom will be chlorine. And